Hello, this is Brother Cromar from the Math Department at BYU, Idaho, and these videos will be covering inference for two means independent samples. And so here's the outline for these videos. First, I'll introduce what independent samples are. Then I'll follow up with how to do hypothesis testing with independent samples, following it up by confidence intervals, and then wrapping it up with checking requirements for independent samples. Okay, so first of all, dependent versus independent samples. Dependent samples is what we dealt with back in the previous lesson where we did the pair sample t-test or the match pair t-test. But in this, going back to the previous lesson, individuals in one sample are used to determine the units or individuals to be in the second sample. For instance, are sons taller than dads? If we were to pose this question, if we randomly choose the sons, then the fathers are automatically selected. Okay? But for independent samples, individuals in one sample do not dictate which units or individuals are to be in the second sample. So say, for instance, in a stats class, if we wanted to do, say, end of semester exam, and we wanted to compare who does better, males or females, but we took a random sample, so we randomly choose the males and randomly choose the females. The individuals in the female sample do not dictate which units or individuals or the males that are chosen in the second sample. Okay, and so this is what we'll be focusing in on is where we have independent samples where the individuals in one sample do not dictate the individuals in the second sample. Okay, so now let's talk about hypothesis testing. Let's review hypothesis testing. This is the very first hypothesis or the steps to do a hypothesis test, and this is where we dealt with one mean sigma known. And so first we stated the null and alternative hypotheses for that. Then we computed a test statistic, but with the one mean sigma known. It was basically using a z-score. Then from that z-score we went to the applet. Since the applet represents a z distribution, we went to the applet to get our p-value. And then we reject the null hypothesis if the p-value is less than the level of significance. If not, then we don't reject. And then we state our conclusions based on whether or not we rejected the null hypothesis. If we reject the null, we have sufficient evidence to say that, and then we state the alternative in English. If we don't reject the null, we have insufficient evidence to say that, and then we state the alternative in English. Okay? And then we dealt with matched pairs, or excuse me, not matched pairs, but the one mean sigma unknown. Okay, we'll get to matched pairs in a review matched pairs in a sec. But basically, with one mean sigma unknown, we also stated the known alternative hypotheses. We computed a test statistic, but then we also got a degrees of freedom as well as a p-value. We got degrees of freedom because we need to know the degrees of freedom because we're dealing with a t-distribution. Well, for all of these three steps, steps 2 through 4, or 2 through 4, we use either Excel or SPSS depending on which class you're in. But then the last two steps is the same as the last two steps in the previous one. We reject the null if the p-value is less than alpha. If not, we don't reject. And then in our conclusions, if we reject the null, we have sufficient evidence to say that, and then we state the alternative in English. If we don't reject, we have insufficient evidence to say that, and then we state the alternative in English. Okay? So then we got to, and this is where we dealt with matched pairs. This is how we define the null and alternative hypotheses for matched pairs. Okay? Here's the null, where the mean of the difference is equal to 0. And the alternative is that the mean of the difference is either less than 0, greater than 0 if it's a one-sided test, or not equal to 0 if it's a two-sided test. Okay? And then steps 2 through 4, we use the software as well to get that. And then the last two steps are the same. We reject the null if the p-value is less than alpha. If not, we don't reject. And then we state our conclusions based on whether or not we reject the null hypothesis. Okay? So now we're going to talk about independent samples, and this is going to be this for dealing with hypothesis testing. So there's going to be 6 steps that we'll be doing with independent samples. It's similar to the 6 steps that we did with matched pairs as well as one mean sigma unknown. It's the same. It's really the same 6 steps, but now how we define the null and alternative hypothesis is different, or hypotheses is different. The null is that mu1 is equal to mu2, meaning the population mean of group 1 is equal to the population mean of group 2. The alternative is that the population mean of group 1 is not equal to the population mean of group 2 if we're doing a two-sided test, or the population mean of group 1 is greater than the population mean of group 2, or the population mean of group 1 is less than the population mean of group 2. It depends on the test, whether we're doing a two-sided test like we're doing here, or a one-sided test, either a right-sided or a left-sided test. Then steps 2 through 4, we do the same thing. We compute a test statistic, determine the degrees of freedom, and get a p-value. This is the formula for getting the test statistic, but basically you'll be using software, whether Excel or SPSS, to get your test statistic. But the same last two steps are the same. We either reject the null or not. If the p-value is less than alpha, we reject. And if it's greater than, we don't reject. And then we state our conclusions based on whether or not we rejected the null hypotheses. Okay? So let's go through a couple of examples using independent samples. And both of these examples are on the online textbook. Okay? So researchers led by Arlene Butts published a study on reading practices of children. They wanted to know if there was a difference in the reading practices of children with developmental or behavioral problems. The DEV group, or Group 1, compared to the children in the general population who did not have developmental problems, the Gen group, or Group 2. One of the factors they considered was the number of nights each week the children participated in reading at home. Data representative of their results are given in the file Reading Practices, and there's a link to it on the online textbook. And then they used a level of significance of 0.05. Okay? They wanted to see if the number of nights in each week the children participated in reading at home, whether or not there is a difference. Okay? So the step 1 is that state the null and alternative hypotheses. So the null is that the population mean of Group 1, which is, say, the developmental group, is equal to the population mean of Group 2, which is the general group, or from the general population. The alternative is that those population means are not equal. Okay? Now, where we get steps 2 through 4 is from software. Now, I have an example of this some output in SPSS. You would see this same output in Excel. But this is, so we're going to use the bottom row. Now, there's 2 rows. The equal variance is assumed and not assumed. Suffice it to say that because it's always right to use equal variance as not assumed, we're going to use equal variance as not assumed. And this is where we get the test statistic, degrees of freedom, and our p-value. Now, for SPSS, this is our, if it's a two-sided test, which this problem is, then this would be our p-value. So this is our test statistic, degrees of freedom, and our p-value. Okay? And so now, first of all, if we look at this 1.455, that means that our result is 1.455 standard deviations away from the null hypothesis. Would this be a rare event or an unusual event? Well, it probably isn't, but the way to check it ultimately is to look at the p-value. Okay, and our p-value is 0.147. Okay, so, but now compared to our level of significance, this is where we ultimately check to see whether or not it's an unusual value. Since our p-value is greater than level of significance, 0.147 is greater than 0.05, therefore we don't reject the null hypothesis, and therefore we have insufficient evidence to say that there's a difference in the mean number of nights each week that children participated in reading in the home between the 2 groups. Okay? Now let's go through the second example. If you want to, you can stop the recording here. Or stop the video and do it yourself. And do the 6 steps. Okay, so here's the problem here. This is a fun problem. The FIFA World Cup of Soccer is held every 4 years, and one of the biggest sporting events in the world. In 2006, Germany hosted the World Cup. A study was conducted by Dr. Wilbert Lampin et al., which means others who were involved, to determine if the stress of viewing a soccer match would increase the risk of the heart attack of another cardiovascular event. We'll use the data on cardiovascular problems during the World Cup to test the hypotheses that the mean number of cardiovascular events is greater than during the World Cup than during the control period. Let Group 1 be the days in the control period, let Group 2 represent days during the 2006 World Cup, and we'll use a level of significance of alpha equal to 0.01. So what I'm going to do is this would be a good time, if you haven't, to try to grab this data from the online textbook and go through the 6 steps of doing independent samples. And then when we get to part 2 of this video, we will go through the answers to this problem.